In this session, we will discuss about FFT algorithm for n equal to 8. Radix 2 Coulomb-Tokay's decimation time fast Fourier transform, that is DITFFT Flowgraph for n equal to 8. So derivation of this flow graph is always two-step procedure. First step to derive DITFFT equation and second step to derive DITFFT flow graph. In first step we will derive DITFFT equation by decomposing x of k in terms of 2 n by 2 point DFT. This derivation we already discussed for n equal to 4. The same derivation and the same equation will derive it, that is x of k equal to g of k plus wn raised to k h of k. Here x of k is n point DFT, g of k is n by 2 point DFT and h of k is again n by 2 point DFT. So this equation decompose this n point DFT x of k in terms of 2 n by 2 point DFTs. What is g of k? G of k is 4 point DFT and h of k is 4 point DFT. For n equal to 8, g of k is 4 point DFT and h of k is 4 point DFT such that g of k equal to DFT of x of 2r and h of k is DFT of x of 2r plus 1. X of 2r means x of n for any one, that is x of 0, x of 2, x of 4 and x of 6. H of k is DFT of x of 2r plus 1, that means x of n only for n odd. Now this is three-step procedure. First step to find g of k, second step to find h of k and third step to find x of k, everything graphically. G of k is DFT of x of 0, x of 2, x of 4, x of 6 and the corresponding output will be g of 0, g of 1, g of 2, g of 3. So at this point in time we will assume that these calculations are done by following DFT formula. In second step, let's calculate h of k, that is DFT of x of 1, x of 3, x of 5, x of 7 and the corresponding output terms will be h of 0, h of 1, h of 2 and h of 3. Output is always in order. Input is decimated order, alternate values. This is only for even terms and this is only for odd values of n. Now the last equation is to find x of k. This equation we have to evaluate for every value of k. So let's start with DITFFT equation, that is x of k equal to g of k plus wn raised to k h of k. In this equation put k equal to 0, we will get x of 0. This x of 0 equal to g of 0 plus h of 0 multiplied by wn raised to 0. Similarly, to find x of 1, take g of 1 plus, in DITFFT equation, when k is 1, we get x of 1, that is g of 1 plus wn raised to 1 h of 1. Graphically, bring g of 1 here, bring h of 1, scaled it by wn raised to 1 and then add it with g of 1, resultant value x of 1. So g of 2 plus h of 2 into wn raised to 2, g of 3 plus h of 3 into wn raised to 3, addition will get required values of x of k. Now, to find k equal to 0, g of 0 is not there, so it is g of 0. G of 4 is not there, so we will take g of 0. If you take g of 0, you have to take h of 0, multiplied by wn raised to 4. H of k terms are always multiplied by wn term. So g of 1 plus h of 1 multiplied by wn raised to 5. And this way, each time we have to just keep on adding the terms and get this x of k. Now, in this first step, we have calculated g of k, assuming that g of k is done by DFT. But the same thing can be done using FFT flow graph. The FFT flow graph for n equal to 4 we already derived. So let's replace this DFT block by FFT flow graph. When we replace this DFT block by FFT flow graph, input order will change. Order will be always alternate order. So DFT replace it by FFT, order of the DFT block changes. This order is always alternate order. That is g of 0, x of 0, x of 4, x of 2, x of 6. And here 1, 5, 3, 7. DFT replace it by FFT, order of the input changes. Now we are going to substitute wn term, but before that let's focus on this h of 1. H of 1 is taken in this direction, h of n is taken in the further direction and multiplied by wn term before it is added with j of 1. Instead of multiplying it by wn raised to 1 afterwards, let's multiply it before only. So this wn raised to 1 term will cancel it and will bring it before it is split. If you take wn raised to 1 here, wn raised to 4 will get changed. So wn raised to 2 will bring it down. wn raised to 2 will be removed. And this way, every term will bring it down. Now, everywhere w raised to 0 is 1, w raised to 1, w raised to 2, w raised to 3 will not substitute because it's a complex number, but w raised to 4 is always minus 1. So, by substituting wn raised to 4 by minus 1, we get this. Now, look at this first stage. Horizontal branch is scaled by minus 1. Second stage, every cross, every butterfly, horizontal branch is scaled by minus 1. Third stage, butterfly, horizontal branch is scaled by minus 1. What does it signify? It signifies summation and subtraction of two terms. Now, this is final flow graph for n equal to 8. This is DITFFT flow graph for n equal to 8. Let's take one example on this. X of n is 1, 2, 3, 4, 5, 6, 7, 8, 8 values. We want to find x of k using DITFFT. X of k using DITFFT we'll have to calculate. So x of 0 is 1, x of 1 is 2. Always go in order of x of n. X of 2 is 3, x of 3 is 4, and so on. For every butterfly, addition of the input at the upper branch, subtraction of the lower branch. 1 plus 5, 6. 1 minus 4, minus 4. 3 plus 7, 10. 3 minus 7, multiplied by minus j. So this is 4j. 2 plus 6, 8. 2 minus 6, minus 4. 4 plus 8, 12. 4 minus 8, minus 4 multiplied by minus j, that will become 4j. Summation at the upper branch. 6 plus 10 for butterfly, 16. Lower branch, minus 4. Each time, sum at the upper branch and difference at the lower branch will get this answer. Now the calculation of third stage, I recommend to do it separately. So let's do this. X of 0 equal to 16 plus 20, that is 36. X of 1 is addition of these two numbers. By substituting w term, we get this value. And by simplifying w term and substituting in this expression, we get all 8 values of x of k like this. This is x of k. Example. Let's take x of n equal to 1, 2, 3, 4. First part of this question is find x of k using DITFFT, and second part is to find DFT of p of n, that is DFT of 10, 20, 30, 40 using x of k. First part is directly using DITFFT flow graph. We'll take the input in alternate order, and by following this procedure, we'll get x of k equal to 10 minus 2 plus 2j minus 2 minus 2 minus 2j. Now in this question, we have to find p of k using x of k. P of k in terms of x of k is possible only when p of n is possible to write in terms of x of n. So first you have to compare the samples of p of n with x of n, and then you have to write p of k in terms of x of k. We can easily make out that alternate values are 1, 2, 3, 4, which is exactly same as x of n. That means p of n is related to x of n. That relationship you have to exploit using DITFFT algorithm. So to find this p of k, we'll start by DITFFT equation. P of k equal to g of k plus wn raised to k h of k. X of k we already calculated. Now we have to write p of k equal to g of k. What is g of k? G of k is DFT of x, p of 2r. P of 2r means p of 0, p of 2, p of 4, p of 6. That is 1, 2, 3, 4. And that is exactly same as x of n. That means DFT of 1, 2, 3, 4 is x of k. Similarly, to find h of k. H of k is DFT of p of 2r plus 1. All those values are 0. That means DFT of 0 is 0. By substituting this value of g of k and h of k, we get p of k equal to x of k, which is p of k in terms of x of k. And now we have to evaluate this equation for every value of k. So let's put k equal to 0, k equal to 1, k equal to 2, and k equal to 3. You will get x of 0, x of 1, x of 2, x of 3, which is already calculated. The next part is p of 5, p of 4, p of 5, p of 6. X of 4 is not there. X of 4 is same as x of 0, that is 10. X of 5 is same as x of 1, that means these values will get repeated here. This is p of k. We are getting repeated answer because p of k is 8 point DFT and x of k is 4 point DFT. So 8 values.
Coursera is an online learning platform designed to provide high quality structured education in a flexible and accessible way. The platform offers academics and professional courses across science, technology, engineering, and management. Visit www.coursera.in. Midnight Masterclass is a YouTube channel, and we welcome you to Midnight Masterclass, your late night destination for learning that is actually fun.
Thank you.